In our last video, we defined what we meant when we talked about quadratic functions, and we said that they are these functions that happen to be of the form f of x equals ax squared plus bx plus c, where a is not equal to 0 and a, b, and c are real numbers. We had also mentioned in the last video, however, that we could also rewrite this in a different way where it could be written this way. And the reason why I want to pick on this is because this is the way that we tend to use when we transform the graph of our parent function. Okay, we have some a value and then h and k, which kind of denote translations, left and right, up and down, shift, with some vertical stretch involved and maybe some reflection. So that being said, basically I want to kind of provide a reason for taking the time to take something that's written this way and rewrite it into this way here, which is what we refer to as vertex form. Okay, so basically this video is going to be how to take something that's in standard form and rewrite it into what we call vertex form so that it looks like this, so that we can graph it easily. So we're just going to kind of run through a couple of examples here. If you are tuning into this video, the whole idea is to be able to graph quadratic, but essentially what we're going to be practicing in this video is what we call completing the square. Okay, so notice that this function here, what I want to do is this. I want to find the vertex, the axis of symmetry, and I want to sketch. Okay, and then maybe domain arrange, something like that. But in terms of finding the vertex, I'll tell you what, if it was written like this, it would be really convenient. But it's not written that way, it's written in standard form. So what we're going to do is we're going to take the standard form and we are going to switch it into vertex form, and here's how we're going to do it. Now, completing the square works kind of like this. I don't know if you've noticed here, but we say x squared plus maybe 4x plus 4. If we were to factor this, okay, remember factoring a trinomial where a is 1, we could say find two numbers that multiply out to be this constant term that add up to be the middle coefficient. In this case, I say I can think of 2. I can think x plus 2, x plus 2. Okay, how about x squared plus 6x? Let's do minus 6x. Let's do that, minus 6x plus 9. We say think of two factors that multiply out to be a positive 9 that add up to be a negative 6. I can think of 2. I can say x minus 3 and x minus 3. Okay, well, how about one more? We say x squared plus 10x plus 25. Okay, and in this case, say think of two numbers that multiply out to be 25 that add up to be 10. I can think of 2, we say positive 5 and positive 5. In each of these cases, what I want us to see is essentially this. We could take these and say it is really just rewritable as the square of a binomial. Okay, and so the whole idea is to be able to take something that is a trinomial like this and rewrite it as the square of a binomial, because look at this. This looks very much, let me trace this back over here, it looks very much like this. So essentially, if I knew of a way to take something that was a trinomial and rewrite it as the square of a binomial, I would be sitting on top of something pretty cool, because then I could take something that's in standard form and I could rewrite it into what we call vertex form. So that's going to be the trick we try to pick up on here. You notice that all three of these expressions that I gave you to begin with factor down into squares of binomials. And there's a reason why that these things happen. Now you're going to notice the first one is this. These all had a leading coefficient or an a value of 1. Our a value is 1. Okay. That being said, though, what I want you to notice is we had a trinomial where if you were to take the middle term, okay, and you take half of it, so that is, if I were to take 4, split it in half, and square that, that would be the same thing as 2 squared, I would get 4, which is equal to the last number. Same thing here, if I were to take the middle term, which is negative 6, and split it in half and square it. Notice that I get this, I get negative 3 squared, which equals 9, which is my last term. And last but not least, we say if I took half of 10, if I took 10 halves, and we squared it, I would get 5 squared, which is 25, which is this last term. So essentially, here's the deal. When we complete the square, what we're trying to cause to happen is this. We say maybe we're not rolled to 5, first of all, we say 6x. Maybe I have an expression like this now. What I really want to cause to happen is I want it to factor down into something like this. But what I've noticed is this. It never happens unless the leading coefficient is 1 and half of the middle term squared comes out to be the last term. So my first question here is this. What would I want to put in for this number right here that would cause this in the first place to be like one of these perfect square trinomials up top here? Okay, so we say we want half of b squared. Okay, and when I say b, I'm talking about this middle value up here in our standard form. So we're going to take this middle term, 6, we're going to take half of that, which is 3, and we're going to square it. So I get x squared plus 6x plus, now half of 6 squared is 6 halves squared, is 3 squared is 9. Okay, so this would be a perfect square trinomial now. And even better, when you factor this, what I want you to see happen is this. I knew that this had to be a 3, and the way that I got this was it was just this. We say it's half of middle term. Half of middle term. Okay, so here's what we're going to do. We're going to take something like this, that, by the way, is not a perfect square trinomial, and I'm also going to rewrite things like this with a y instead. What we're going to do is we're going to cause this to be a perfect square trinomial. So we're going to break this down into steps, and number one is this. We say boot the constant, okay? Boot the loose term. And by boot the loose term, what I mean is this. Let's take this 1 and let's put it over here. So we're going to add 1 to both sides, and I get this. Y plus 1 equals x squared minus 6x plus blank. Now I'm putting a blank here, and the reason why is because I'm going to put in this blank what I would want to have there so that it does factor down into a perfect square trinomial. And you'll notice in this case our middle term is negative 6. So for instance, if I were to take half of negative 6 and square it, that's what's going to go here, by the way. We say that would be negative 3 squared, and negative 3 squared is 9. So I'm going to put a 9 here. The thing is, once you put something on the right side of an equation, you also have to add it to the left. So one piece of advice I give is when you put plus blank here, let's put plus blank on both sides. So the left side now, if you combine your 9 and your 1, we have this. We have y plus 10. And on the right side, we have x squared minus 6x plus 9. Now, I didn't have to rewrite this right side. Actually, what we could do right now is the thing we were trying to do in the first place, which is factor it. And the best thing is this. I don't even have to write this as x minus 3 times x minus 3, which it is. What I can just do is say this is x minus 3 squared, and the reason why is because I took it times itself. And how do I know this will be a negative 3 in here? I just took half of the middle term here. So the last thing I want to do is this, okay? So we said boot the constant. Step 2, we'll go backwards here. Step 2 is add this, b halves squared to both sides. Okay, and then we factored, and then we also isolate y. Okay, so what we're going to do here is get y back by itself. So if I were to take 10 away from both sides, what we would end up with is this. We'd say y equals x minus 3 squared minus 10. Now the nice thing about this is that I can tell you instantly where its vertex is. We say, well, the vertex would have to be at h and k. So our h value here is positive 3, and our k value is negative 10. Okay. When I look at this, I say, well, what's our a value? Well, our a value is 1. We say a equals 1. So we could say something about this. We say it opens upward. We know this. And, you know, it looks something like this. 3 to the right, 10 down. We'd have a vertex here, and our axis of symmetry running through the middle of it. We say our a value is 1, so I'd go up 1, right 1, up 1, right 1, up 1, left 1. And we're going to label all of these points. Sorry about missing that one right there. But we say this is the point here. 3, negative 10 is our vertex. This point here went up 1, right 1. So we went right 1, so we're at 4. We went up 1, so we're at negative 9. And at this point right here would have to be this. It would have to be 2, negative 9. Okay. The axis of symmetry is the only thing we had left to find, and it's just going to be this. X equals 3. And that's just because it goes through 3 right here. So the whole point of this story is this. If somebody gives you something that is in standard form, let's just complete the square and put it in vertex form.